In this lecture, we talk about interval regression. Now, sometimes we do not know the exact value of the response variable or the observation, but we know the interval it falls in. And to model such a data, we need interval regression. For example, the response variable of the salary of a candidate, this may not be known exactly, but you know a range in which this falls in. And this is true for survey data. For example, in survey data, you do not know the exact value, but you know the range of the response variable. Now let us give an example. So say you have a candidate whose range of salary you know. So say this is row 1, tells about candidate 1. His lower range is $62,500 and upper range is $75,000. So the salary falls between this range. So this is in thousands of dollars. So this is his response variable. So response variable is not a single value but an interval. And your input or your predictors are math score, GPA and race. So race is categorical variable. So math and GPA are continuous. So this individual one, he has math score of 39, GPA is 3.33 and race is 1. In row 2, you have data where you know the salary range. It ranges from $80,000 to $90,000. Math score is 48, GPA is 4 and race is 2. Now the third individual, his salary is between $41,000 and $63,000. Math score is 50, GPA is 2.75, race is 3. The fourth individual, row 4, his salary is between $51,000 and $53,000. Math score is 25, GPA is 2.89, race is 1. So you need a model in which your output is salary of say a student passing from a university, and your input is math, GPA and race. So math score, GPAs and race of the student, and the output you get is salary, but your observation is an interval. Your observation is not one particular value, it is an interval. So for such a model you need interval regression. So we do this in R. First you clear the memory, you require the survival package, so install it if you do not have it. D4 is your data set, this is the address and this is the name of the file. Your header is true. So row 1 gives you the lower range of the individual, $62,500. Upper range is $75,000 for the salary of individual 1. His math score is 43, GPA is 3, race is 1. Row 2, the lower value is $85,000, upper value is $95,000. Math score is 31, GPA is 3.78 and race is 2. Notice that these intervals have different lengths, so you do not have to make them of the same length. So your model is like this. You input 3 values, math, GPA, race, and you get salary. So we have to have some salary Z and input into the model is our math score, GPA and factor race, because race is a categorical factor, so we have to factor it out. So before we can do that, we have to make sure that the system knows that the Z is coming in interval form, it is not coming in standard values. So first you take the Z and you say with D4, T4 is our data set right here. You use the survival package here, use the lower and the upper intervals. So this is the interval values, and you make Z into some kind of an interval input into the data. So this is a standard command, so you can just copy paste it from the description of the video. So you just see what first 2 values of this is. So first 2 value is 6.25 to 7.5. This is precisely this value. And the second value is 8.5 to 9.5, exactly this value. So basically you have taken these 2 values and made them into one variable. So this entire thing becomes Z. And that is precisely the way you can feed in data and make a model in R. So now you have this model. This is Z. Then you have math score, GPA, factor race. You're precisely copying this here. Your data is D4 and you use the Gaussian distribution. So once you run this model, you take its summary. Now the summary comes out like this. So luckily we have p-values here. So if the p-value is less than 0.05, then that coefficient is significant. Now if it is greater than 0.05, then that coefficient is not significant. So this is less than 0.05, significant, significant. Now this is not significant because this is greater than 0.05. So GPA is not a significant factor in our model. So race 2, this is significant, this is significant. So now let us interpret this model. So math value is 0.05. So if math score goes up by 1, then your salary will go up by 0.05 in terms of thousands of dollars. So you have to multiply 0.05 by 1000 because we input the salary in thousands of dollars. Now if race changes from 1 to 2, your salary goes up by 0.818. So if your race changes from 1 to 3, then your salary goes down because there's a negative sign. Your salary goes down by 0.96 in terms of thousands of dollars. So you have to multiply this by 1000 and you have to multiply this by 1000 if you want exact salary. Now since GPA is not a significant factor, for prediction purposes we have to drop GPA. So you make a new model M6 in which you keep the Z, but you now have math and race as the only factors. You have dropped GPA out. Your data is the same data set D4, distribution is Gaussian. This is your data frame. Your math score is 40, 40, 40. Your race is 1, 2, 3, 1, 2, 3. Now you predict model M6, put in this data set S1 right here. Your type is response. So you feed in 40 into the model, race is 1. Your salary comes out to be 7.79. So that is times $1,000. If you feed in 40 and race is 2, this comes out to be 8.89 times 1000. And if you feed in this third row, race 3, again the math score is constant, only the race is changing, 6.92 times 1000. So you can see from here also, if your race changes from 1 to 3, you expect a negative impact. So your salary is going down. But if your race changes from 1 to 2, there is a positive impact. So your salary is going up. So that is it. You can now put in any number of values for your math score and your race, and you can get different outputs.